Hi students, welcome to Sunil's tutorial. I'm Sunil Milwani and today we'll be doing the sums of pair of straight lines. Let's start. If the line px plus qy is equal to 0 coincides with one of the lines given by ax square plus 2hxy plus by square is 0, show that aq square minus 2hpq plus bp square is 0. Okay, let's see the sum. Now I can say that let y is equal to mx represent one of the lines of ax square plus 2hxy plus by square is 0. Now since y is equal to mx represents one of the lines of this pair of lines, therefore the equation y is equal to mx should satisfy the equation of pair of lines. Therefore I can say that ax square plus 2hx y can be written as mx plus b mx the whole square is 0. So you will get therefore ax square plus 2h mx square plus b m square x square is 0. Therefore if I divide by x square, I'll get a plus 2hm plus bm square is 0. All this is equation 1. Okay, that means if y is equal to mx, then this is the equation that is formed for the pair of lines, or y is equal to mx is satisfied by the slope of this. Okay, now equation of line given to you. Equation of line is px is equal to px plus qy is 0. Therefore I can say that qy is minus px. Therefore y is equal to minus p upon qx. This is in the form y is equal to mx. Therefore slope of this line is minus p upon q. Since the two lines coincide with each other, their slopes should be equal. That means I should be able to substitute this slope in this equation, substituting slope in equation 1. So I'll get a plus 2hm, m can be written as minus p upon q, plus bm can be written as minus p upon q, the whole square is 0. So I'll get a plus minus 2hp upon q plus b p square upon q square is 0. I could take q square as the common denominator, so I'll get aq square minus 2hpq plus bp square is 0. Take q square on the other side, so I'll get aq square minus 2hpq plus bp square is 0. And I presume that's exactly what you have to do. Fine, this finishes the sum. Let's move on to the next sum, guys. If one of the lines given by ax square plus 2hxy plus by square is 0 is perpendicular to lm plus my is equal to 1, then show that AL square plus 2HLM plus BM square is 0, right? Identical to the previous sum, you will say let y is equal to m1x represent one of the lines of the equation ax square plus 2hxy plus by square is 0, right? That means I should be able to substitute the value of y as m1x in the equation. So therefore I can say that ax square plus 2hx m1x plus b m1x the whole square is 0. So you will get ax square plus 2h m1x square plus b m1 square x square is 0. Divide by x square. If I divide by x square, I will get a plus 2h m1 plus b m1 square is 0. Let's call this as equation 1. Now, the equation of line given to you, is given to you as lm plus my is equal to 1. Therefore, I can say that my is minus lm lx. The equation of the line given to you is lx. So I can therefore say that my is minus lx minus 1. Therefore you can say y is minus l upon mx minus 1 upon m. This equation is in the form y is equal to mx plus c. That means I can therefore say that slope of this line is minus L upon m. But this line is perpendicular, this line is perpendicular to one of the lines which is represented by the pair of lines. Therefore I can say that slope of perpendicular line is negative reciprocal. So that will be nothing but m upon L. Once I know the slope of the line, I can substitute it in equation 1. Substitute slope in equation 1. So I will get a plus 2h. m1 can be written as m upon L plus b m upon L the whole square is equal to 1. So a plus 2hm upon L plus b m square upon L square is equal to 1. al square plus 2hml plus bm square is equal to we're substituting in this is 0. So this will be 0 because equation 1 right hand side is 0. So a plus 2h m upon L plus b m upon L the whole square. So you will get this. You've taken L square as the common denominator and take L square on the other side. You will get your answer. Fine. Do we get this? Next, let's move on to the next sum, guys. The slope of one of the lines represented by the equation 3x square plus 4x y plus lambda y square is 0 is 3 times the slope of the other line find lambda, right? Now, equation of pair of lines is given to you as 3x square plus 4xy plus lambda y square is 0. This equation is in the form ax square plus 2hxy plus by square is 0. If I compare the two equations, I can say a is equal to 3, 2h is equal to 4 and b is equal to lambda, or lambda is equal to b. Right? Now once you have this, let m1 and m2 be the slopes of the two lines. If m1 and m2 are the slopes of two lines, then I can say that m1 plus m2 is nothing but 2h minus 2h upon b. m1 plus m2 is minus 2h upon b. So I can therefore say that m1 plus m2 is minus 4 upon lambda. Right? Do we get this thing clear? Let's call this as equation 1. And I can say m1 m2 is going to be equal to a upon b. So I can therefore say that m1 m2 is a 3 upon lambda. Let's call this as equation 2. But they have given you that slope of one line is 3 times the other. m1 is 3 times m2. Substitute in equation 1 and 2. If I substitute this in equation 1 and 2, instead of m1 I'll write 3 times m2 plus m2 is minus 2h upon b. 4 times m2 is minus 2h upon b. m2 is minus 2h upon 4b. So this is minus h upon 2b. Similarly, if I substitute in equation 2, I'll get 3 times m2 into m2 is 3 upon lambda. So I'll get m2 square is 1 upon lambda. But we have just found out the value of m2 to be this. Substitute the value of m2 here. So I'll get minus h upon 2b. The whole square is 1 upon lambda. Right? If we solve this, you will get this as h square upon 4b square is equal to 1 upon lambda. But we know the value of h. H is 2. So h square is going to be 4 upon 4b square. Lambda square is 1 upon lambda. 4 and 4 gets cancelled. 1 upon lambda square is 1 upon lambda. Cross multiply, you will get lambda square is equal to lambda. Therefore lambda square minus lambda is 0. Lambda common, lambda minus 1 is 0. Either lambda is equal to 0 or lambda is equal to 1. But lambda cannot be 0. If it is 0, then this equation will not represent a pair of lines, but lambda is equal to 0 is not possible. Therefore I can say lambda is equal to 1. Right? Let's move on to the next one, guys. If slope of one of the lines given by ax square plus 2hxy plus by square is equal to 0 is k times the other, then prove that 4kh square is equal to AB 1 plus k the whole square. Fine. Now, equation of pair of lines. Equation of pair of lines is given to you as ax square plus 2hxy plus by square is 0. Right? Now, let m1 and m2 be the slopes of the two lines. Now they've given you that slope of one line is k times the other. That means I can say m1 is k times m2. But we know that m1 plus m2 is nothing but minus 2h upon b. Right? Now instead of m1 I can write k times m2 plus m2 is minus 2h upon b. m2 common, k plus 1 is minus 2h upon b. Therefore you could say that m2 is minus 2h upon b k plus 1. Call this as equation 1. Also you can say that m1 plus m1 into m2 is nothing but a upon b. Now m1 can be substituted as k times m2 into m2 is a upon b. m2 square is a upon kb. Fine, do we get this thing clear? Now let's call this as equation 2. Substitute the value of m2 from equation 1 to equation 2. So in which case, see, substitute m2 from equation 1 to equation 2. So in that case you will get minus 2h upon b k plus 1 the whole square is equal to a upon kb. This is 4h square upon b square k plus 1 the whole square is a upon kb. So you can therefore say b and square gets cancelled. So you will get 4kh square is ab k plus 1 the whole square, and that is exactly what we had to prove. Right? We'll stop here for the day. Thank you very much.